Let's have a look now at the sine rule. This is something we can use for non-right angle triangles. So previously we've been working with the trigonometric ratios, sine, cos and tan, okay, and they relate to right angle triangles. But we've got a couple of rules we can use now when we're working with triangles that are not right angles. So here's an example triangle. I'm going to label the vertices A, B and C. Now the sides, very important we get comfortable with how we label the sides. So the side opposite our capital A angle, remember we call it little a. This is the side opposite our B angle, so we're going to call that little b, and correspondingly this will become side little c. Here is the sine rule written out for you. It's A over sine A equals B over sine B equals C over sine C. Now let's go through and have a look at an example of how we can use that. Here's a sample triangle and we're wanting to work out what is the length of side X. Now we can see that it's not a right angle triangle given these angles, so we're not going to be able to use our trigonometric ratios, but we are going to be able to apply this sine rule. The first thing we're going to do here is we can work out the third angle, because remember the angle sum of a triangle is 180 degrees. So they all have to add up. All three angles inside any triangle always add up to 180 degrees. So we'd take 180, take away the 30 and the 110. We know that that angle there is 40 degrees. Now that's going to come in handy for us to use our sine rule. I'm going to label this triangle XYZ. Okay. And I did it this way because I wanted little x here, so I'll put the corresponding angle as a capital X. So now I can rewrite my sine rule. In this case, I've got x over sine x equals y over sine y. Now I can start to fill in the things that I know. For example, I know sine x, okay, because that is this angle here. So it's the sine of angle x, which is 110, so sine 110. I know y and the angle y, okay, because I've got the angle y here, I know is 40 degrees, so I can do sine 40 for that, and the corresponding opposite side we're given as 6. So I can fill in all the things I know, and the only unknown I've got here is x. To get x on its own, I'm going to multiply both sides by sine 110. This is just some basic algebraic manipulation so that I can get x on its own, and that's something we can put into a calculator, and it works out to be that x equals 8.8. Let's have a look at another example. We've got using the same sine rule. Now this way we're going to have two options. There's two ways we can work this out. I'm going to do it both ways for you, and you decide which one works better for you. Okay, because in this case our unknown is an angle rather than a side. So it's going to be on the bottom when we write out our sine rule. So here I've written out A over sine A. Okay, so I've got the sine, I've made this sine alpha. Okay, that's this part here, and the corresponding side is 20. So it's that side over the sine of that angle equals this side over the sine of its corresponding angle, and that's where this equation comes from. Now in this case I've got my unknown on the bottom, so the algebra could get a little bit messy, but what I'm going to do to make it a bit easier is simply cross multiply across this equation. Okay, so I'm going to do 20 times sine 15 equals 9 times sine alpha. So I'm just cross multiplying across the equal sign. That gives me my unknown over here, and I can simply divide both sides by 9 to get the sine alpha on its own. Now that's great. I can work out what sine alpha is, but to find alpha I use the inverse sign. So I bring the sine across to this side, make it an inverse sign, and I can calculate a value for my angle alpha, which works out to be 35.1 degrees. Now there is another way which is a little bit shorter or easier, and that is we can simply flip this sine rule on its head. Okay, we just invert these fractions so that now sine A over A equals sine B over B. We're quite okay to do that. We're allowed to do that. So now when I fill in my unknowns, my sine alpha is on the top, and I no longer need to cross multiply to get in on its own. I simply take both sides and multiply them by 20, and I end up at the same point that I ended up here. Okay, you'll see that these two expressions are identical. This way was just a shorter step. In getting there, we took out the cross multiplying step, and then from there obviously the calculations work out to be the same. Okay, so it's completely up to you which one you use, but remember you can flip the sine rule on its head, and certainly this second option is probably the quickest and the easiest way of doing things. Right, that's the sine rule.